Hello and welcome to Slam TV. I'm Professor Roger Yang, and we've got a great episode for you folks today. Today we're going to be learning about measures of center. Luckily for you folks at home, we've got a very special guest for you. He's known as the stats savant. He's smoother than a stats ninja. He's an outlier of awesomeness. He's Professor Jay Joe.
Thank you, Roger.
Hey, Jay. How's your relationship with Leo going?
I'm flying. Jack.
Who?
Leo? You're not still dating Leo?
Oh, Leo.
Yeah,
I'm
Leo.
sorry. That's so 3 months ago.
Oh, you guys are like overs?
No, sorry. Actually, I created a new profile on this online dating website.
What website is this?
It's called,
What's your cosine.com?
it's for people who's looking for love, who love math.
People looking for love who love math. Sounds just like you.
What'syourcosine.com, yes.
Very appropriate. Did you create a new dating profile?
Yeah, do you want to take a look at it?
Sure.
Just an average guy looking for love.
Wait a minute. Average? Is that like adding up a bunch of numbers and dividing by the total average?
Yeah, I'm just average guy, right? Am I not?
Well, since we're talking about measures of center, why don't we review the formula for average with our students?
Okay.
If we took a look at this guy, we can see that on the left-hand side of the equation, we have x bar, which is the notation for sample mean.
Right, and if you look at the right-hand side, you see that big symbol. It's called sigma.
Ah, what does sigma mean?
This is a Greek letter sigma. Sigma in mathematics, though, means you're adding a bunch of numbers.
These xi's are supposed to be the different data values, I guess.
Right, so when you see sigma xi's, that means you're adding up a bunch of data values. And the answer you get is going to be the numerator.
Oh, the denominator I see is the letter n.
Right, that just tells you how many data values you have.
Oh, okay. So we're going to add up all the numbers and then divide by the number of data values.
Right, then that'll just get the mean, which is the average.
Maybe we should do a numerical example with our viewers. So here we have this data set. We have 8, 11, and 12.
Right, so according to our formula, on top you got sigma xi's. That means you're adding a bunch of data values. Here we have 3, so we're adding up 8, 11, and 12.
Okay.
And on the bottom, what's our n in this case?
Our n is going to be 3 because we have 3 numbers.
Right, so you're dividing by 3.
If you're doing this calculation at home and you're trying to do it all in one step, make sure that you put parentheses around the numerator.
Right, it's very important. Otherwise, you're dividing only 12 by 3 and not the entire sum by 3.
Oh, okay. I'm sure our viewers will be very careful with that.
Right.
So when we do this calculation, what do we get? Ooh, we get 10.33333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333
How are you going to write all 3's out? Does it go in forever?
Yeah, it's a repeating decimal. I think we have to
Right.
round it. Is there some standard round-off rule we use?
Right, the standard that we used, the convention is that we round off 1 decimal point beyond how the data set is given.
Oh, okay.
So remember our data set? There are just whole numbers.
Yes.
So when you write out our mean, when you have to round off,
We have to go one more beyond.
right, so that'll be just 10th place value.
Oh, 1 decimal place.
Exactly.
Got
So
it.
instead of saying 10 point, we just go 10.3.
Ah,
And if you look at the next number, it's also 3, so you just stay the same, 10.3.
I get it, Jay. I get how we can calculate the average here. In what way is a totally awesome guy such as yourself average, though?
Yeah, I think I just have an average height as a Korean guy. Not too tall, not too short, right?
Oh, why don't we look up what the average height of a Korean dude is on the internet?
All right.
Oh, it says the average height for Koreans is 5 feet 8.5. How tall are you?
5 feet 8 inches and a half in the morning on a good day,
Oh,
maybe.
okay. So you're basically an average guy when it comes to height.
Right.
Oh, did you know that average, another way to say average is mean? Usually in stats we say mean instead of average.
Oh, okay, got it. That means I gotta update my profile.
Yes.
Just a mean guy looking for love.
How else are you average, Jay?
I think I just have an average income.
Oh, average income. Income is something that average is really sensitive to outliers, actually.
Wait, what's an outlier again?
An outlier is a highly unusual value. It's either extremely large or extremely small compared to the rest of the data values.
It's not inside the normal range of numbers. It's
That's
outside.
right. The mean is actually highly sensitive to outliers. So if you were to add like a 1%er,
Not that kind of 1%er.
no, I mean the super wealthy, like Mark Zuckerberg or Jeff Bezos.
Or my Uncle Jack.
Right, so when we add an outlier, it really is going to affect our mean. And I think we should show our viewers with a couple of numerical examples.
Okay, let's look at some examples here then.
First, let's add an example where we're adding a number that's not an outlier.
Okay.
So our original data set was 8, 11, and 12. Let's add in the number 9 and see what happens.
Right, so now we have 8, 11, 12, and 9. So when you add them all up, I got 4 numbers on the top.
That's right. So when we divide, we have to put a 4 in the bottom since we add an extra number.
Right.
And when we do the calculation, we get...
We get 10, which is not that different from 10.3.
No, so in this case, adding a 9 didn't really affect the mean that much.
Right, so if these numbers are like income, $8, $11, $12, $9, these are pretty normal range of values.
That's right.
So average income is $10, which is not that different from 10.3.
$10? This is like below minimum wage.
Oh, you know what? Maybe this is like old data set from like my parents' generation.
Your parents' generation?
Uh-huh.
Or are these the hourly wages of the first 4 jobs you had?
My first 4 jobs? Convenience store, donut shop, retail, and fast food? No.
Okay, Jay, let's see what happens if we added an outlier. Let's say someone made like $99 an hour.
$99 an hour? That's a lot of money, even for today's standard.
That's right. Well, who knows? Maybe the minimum wage will be $99 when Jay Jr. grows up.
I so hope so.
Okay, so let's see what happens if we add this 99 to our original data set.
Okay, so let's look at the numbers again. So we have 8 plus 11 plus 12 plus 99 on the top.
And we're still dividing by 4 because we added just one extra number, so the total is 4.
Okay, and let's see what the answer is going to be then.
32.5.
Wow, that's significantly higher than what the number they had before, 10.3.
You know what? Actually, 32.5 is even bigger than all of our original data values of 8, 11, and 12.
Right, $32.5 an hour, that's a lot of money.
That is,
Yes.
that is. So as we can see, adding an outlier is going to greatly affect our mean.
Right, you can see because in order to calculate the mean, you're supposed to add up all the data values. So when you have a large number, when you add them up, the sum is going to be also a very large number.
Oh, so adding an outlier makes the numerator much bigger.
But for the denominator, it's only one more because you're just adding one more data value.
Oh, I get it. So because the top blows up and the bottom just increases by a little, the whole thing changes quite a bit.
Right, that's why you said the mean is very sensitive to outlier. Maybe that's not the best way to measure the income because there are a lot of outliers for the income.
Yeah, when it comes to income, we usually don't want to use mean. We want to use the median.
Median? I thought that was a measure of relative standing.
Well, think about how we calculated the median.
Okay,
We put all the numbers in order. We chose the middle guy, right?
right.
So the median is both a measure of relative standing, but it's also a measure of center because it's in the middle.
Oh, it's also a measure of center as well. Okay,
Yes.
so it can be used in 2 different ways.
Right. And the
Okay.
great thing about the median is that it's actually not sensitive to outliers.
Oh, really?
No.
Oh, can we look at the examples and see how this is different than the mean then?
Yeah, let's take a look at the original example. We'll do the median instead of the mean, and then we'll see what we get. What was the median of our original data set, Jay?
The median of our original data set, well, as we talked about before, median, we arrange the number in order, then we're going to pick out the middle number.
Right.
So we have 8, 11, and 12. It's already arranged in order, which is good. Then we're going to just pick out the middle number, which is 11.
Yeah. When we have our new data set, we're going to add the number 9 in, right?
Right.
So when we add the number 9, what's the first thing we need to do?
Well, we have 8, 11, 12, and 9. They're not arranged yet.
Oh,
So we're going to have to arrange it in order.
okay.
So it'll be 8, 9, 11, and 12.
Got it. So I noticed that we have an even number of numbers now.
Right, that means there are 2 middle numbers
I see.
that we're going to just average those 2.
So in this case, we find the average of 9 and 11.
So 9 plus 11 over 2, that gets you 10 as the median.
Oh,
And notice that, $10 an hour is pretty similar to the data set we had before.
right.
So it's not that different than the mean.
I see. Let's see what happens when we add in our outlier value of $99 per hour.
Right.
If we add 99,
Wow, okay, let's look at the median. I have 8, 11, 12, and 99. Fortunately, it's arranged in order.
okay.
So we'll just pick out the two middle numbers.
The two middle numbers are...
11 and 12.
So when I take 11 plus 12 and I divide that by 2, I get 11.5.
Yeah, which is not that different than before, right?
It didn't seem to be affected that much by the inclusion of 99.
Right, so that's why you mentioned that it's better to use median for income because it's not as sensitive to the outlier.
Exactly, because if you think about it with median, when you add an outlier, it just shifts the location by maybe one spot, maybe half a spot.
Right, so even the numbers you're adding is really large, you're just only affecting by one position.
Exactly.
So do you know what the median income is then?
Let me look it up online. Oh, the median income in the United States is $61,000.
Wow, that's interesting. That's exactly how much I make too.
Oh, really? You mean
Right.
you're both the mean and the median?
Oh yeah, wow. Ooh, that means I gotta update my profile again. Just a mean median guy looking for love.
So what other way are you average, Jay?
Well, with my median income, I just bought an average car.
Oh, really? What car did you get?
A RAV4?
RAV4, huh? Hey, wait a minute. You said average car?
Uh-huh.
If I try to add up a RAV4, a Honda Civic, and a Tesla X, I can't add car models.
Oh yeah, that's right. This is not even quantitative data set.
No, this is qualitative data.
Right, because we're not talking about numbers, we're talking about like a name or kinds of car you're doing.
Exactly.
Right. What I actually meant to say was I got the most common car. Dude, the other day I went to Disneyland parking lot. I just couldn't find my car. It took me 2 hours because every other car basically looks like my car.
Jay, you got to use those signs they have in the parking lots of Disneyland, like Goofy 7.
I didn't see it. Yeah, next time. So then instead, what should I use then?
Well, when we have qualitative data, we probably want to use the mode.
Okay, what was the mode again?
If you look at this data set, oh, we have quantitative data.
Right, so mode can be used for quantitative and qualitative data set?
Oh, yeah, that's right. So if we look at this data set, what's the most frequently occurring value?
Oh, I see a bunch of 2s. There are 5 2s. I think these are the most occurring number.
Yes, so that would mean that the mode is 2.
Right. Is there a case where you can have a bunch of numbers that occur the most?
Well, if you have 2 numbers that occur the most frequently, then we call it bimodal.
Right, bi means 2, so there are 2 modes, so it's possible.
If there's many modes, sometimes they call it multimodal.
Okay, and do we always have to have a mode?
No, if all the values are distinct, if they're all different numbers, then there's just no mode.
Okay, I guess. Yeah, okay, I get it. So can we look at the mode for this mode car then?
Sure, let me look it up online.
Okay.
Oh, it says on the internet that the best-selling car last year, which would be the mode, is a RAV4.
Wow, RAV4. I thought it'd be Prius because don't we see a lot of Prius here?
Oh, actually, that's the mode car for the entire United States. Is your population going to be all the US, or are you just limiting yourself to dating people in LA?
Well, I don't want to limit myself here, so yeah, the entire USA.
Oh, okay.
That'd be my population, yes.
Cool. So then you're mean, median, and now you have the mode car too.
Oh, good. Then I gotta update my profile again.
Yes.
Just a mean, median mode guy looking for love in his RAV4 anywhere in the USA.
Okay, folks. Well, I hope you enjoyed this episode. So remember, be safe and choose the appropriate measure of center when finding the center of your data set. Bye now.